Product and Quotient Rules, Part 2. So recall the product rule and the quotient rule. We want to find f prime of x, so the derivative of f of x is equal to 2 minus 3 to the x squared, all over 3 plus x. What's interesting about this particular function is that in order to take the derivative, we'll have to use the product rule for this 3x times x squared, and the quotient rule for the function overall. So let's start by finding the derivative of our numerator and the derivative of our denominator. So the derivative of 2 minus 3 to the x squared will be equal to 0 minus, and then we have to use product rule in order to find this derivative. So we'll have the first function, which is 3 to the x, times the derivative of the second function, the derivative of x squared is 2x, plus the second function, x squared, times the derivative of the first function. The derivative of 3 to the x is 3 to the x ln of 3. And then let's take a moment to factor any common factors between these two terms. So we have a 3 to the x in both terms, and we also have an x. So we can factor out x 3 to the x. So this will be equal to negative x times 3 to the x times, when we factor out x and 3 to the x from the first term, we're left with a 2. When we factor out x and 3 to the x from the second term, we're left with x ln of 3. So that is our derivative of the numerator. Now we can find the derivative of the denominator, so that'll be the derivative of 3 plus x, which will be equal to 0 plus 1, which is just 1. And now we can use quotient rule to find the overall derivative. So f prime of x will be equal to low, so 3 plus x, d high, which is that negative x times 3 to the x times 2 plus x ln of 3 minus high, so 2 minus 3 to the x squared, d low, which is just 1, all over low, which will be equal to 3 plus x all squared. And for your final answer, you wouldn't want to write this one. If it were a paper test, you'd just erase the 1. When we look at this, notice that although we have a 3 plus x in common in the first term, there's no 3 plus x in the second term, so we can't actually divide out a 3 plus x. So this is our final answer for this derivative. Find the second derivative for f of x is equal to x over x squared minus 1. So in order to find the second derivative, we have to start by finding the first derivative. And to find the derivative of this function, we'll want to use quotient rule, because we have a quotient. F prime of x will be equal to low, so x squared minus 1, d high, so the derivative of x, minus high, which is x, d low, which is 2x minus 0, all over low, so all over x squared minus 1 squared. So this is equal to x squared minus 1 minus 2x squared all over, and because we won't be able to take the derivative of this yet. We'll want to square it out. So we'll have x to the fourth power minus 2x squared plus 1. And then simplifying a bit more, we have negative x squared minus 1 all over x to the fourth power minus 2x squared plus 1. And then we'll need to find the second derivative. So f double prime of x will be equal to low of the first derivative, so x to the fourth power minus 2x squared plus 1, d high, so the derivative of negative x squared minus 1, which is negative 2x, minus high, negative x squared minus 1, d low, 4x cubed minus 4x plus 0, all over low, which we can write back in its factored form, so that x squared minus 1 squared again, will be to the fourth power. So that's just the x to the fourth minus 2x squared plus 1 squared. And then we'll want to simplify a bit, but I'm out of room. Okay, let's continue simplifying this. So let's refactor this expression. So we have x squared minus 1 squared times negative 2x. Then let's factor out a negative 1 from that expression. So now we have plus x squared plus 1. Then we can factor out 4x from this expression. So we have 4x times x squared minus 1. And then in the denominator, we still have that x squared minus 1 to the fourth power. Both terms in our numerator have at least one x squared minus 1. And our denominator also has an x squared minus 1. So we can divide out one of those x squared minus 1s. So this one will divide out completely. We'll have 1 left for this term, and we'll have 3 left in the denominator. I also see that there is a 2x in common between each of these terms, so I can factor out a 2x. So this will be equal to 2x times negative x squared minus 1 plus, if I factor out 2x, I'm left with just a 2 times x squared plus 1. And this will be all over x squared minus 1 to the third power. And this is the second derivative of x over x squared minus 1. Now, we could actually simplify this a bit further if we wanted to. The big thing is that we want to make sure that we've factored out all common factors. But when everything sort of has the same powers in that numerator, we can do some distribution. So we have negative x squared minus 1 plus 2x squared plus 2 all over x squared minus 1 to the third power. And this will be equal to 2x times negative x squared plus 2x squared leaves us with just 1x squared, and minus 1 plus 2 gives us x squared plus 1 all over x squared minus 1 to the third power. So that is probably the most simplified version. And if we had to find the third derivative, we'd probably have to distribute that 2x out and also expand the x squared minus 1 cubed. But luckily, we're just looking for the second derivative.